Hello, for our first question, we have that a motorcycle was moving at 20 meters per second. And accelerated. So this is our BI. Accelerated at 5 meters per second squared for 15 seconds. This is equal to our time. Now we're given the formula BFF equals BFI plus AT. We just plug in. BFI is over here. A is over here. And T is over here. (20 meters per second plus 5 meters per second squared times 15 seconds. We multiply this and then we add it over here, and this should equal to 95 meters per second. For number 2, a bus travels 10 kilometers south and then returns around travels 30 kilometers north. What is the car's displacement? So we're given the formula of displacement, and we basically have our final equals 30 kilometers north. X of I is 10 kilometers south. Therefore, now we just subtract minus 10 kilometers south equals to 20 kilometers north. Number 3. An object is accelerated uniformly from 4 meters per second to 8 meters per second in 10 seconds. How far does the object travel in 10 seconds? So we have our formula that we're given, and we're trying to find for how far. Therefore, we're given BFF, we're given BFI, and we are also given time. BFF equals 0.0 meters per second, BFI is 0.0 meters per second, and time is 10 seconds. Therefore, we plug in. It will be 8.0 meters per second plus 4 meters per second times 10 seconds. We should get 8 plus 4, 12 times 10, 120 divided by 2, 60. 60 meters. Now we go to question number 4. A ball at rest falls from a platform above the ground. The ball falls freely and hits the ground 1.1 seconds later. What is the height of the platform? So there we are given the formula. we're given this formula, and initially of the sentence it says a ball at rest. That means that our b of I equals to 0 meters per second. Acceleration equals 9.81 meters per second squared. And our time is 1.1 seconds. Now we plug in here. B of I goes here. A goes over here. And T goes over here. So now and you square this one times this over here. Remember your units, and you should get 5.9 meters. Now let's do question number 5. A train travels north at a speed of 50 meters per second. A passenger walks towards the rear of the train at a speed of 2 meters per second. A person standing on the platform at the train station observes the motion of the passenger and the train passes. According to the information in the diagram above, what is the apparent speed of the passenger with respect to the train? So now we use our, let me start over here. We're going to use our displacement equation. In this case, x of f is 50 meters per second north, and x of I is 2 meters per second south. So now 50 meters per second north minus 2 meters per second south, that is equal to 48 meters per second north. Now next question. One drops a penny from the top of the Empire State Building on the ground below. The height of the Empire State Building is 443. How long will it take for the penny to strike the ground, assuming no air resistance? Remember that this is a free fall. So B of I equals to 0 meters per second. A is equal to negative 9.81 meters per second squared. And our formula is this over here. So now over here, this is our change in y. And remember, you should always be careful identifying everything. So something good to remember is that displacement and distance the units are meters. Okay. For velocity, the units are meters per second, and acceleration, meters per second squared. So now you just apply that over here, this information over here. So now t equals 2 square root of 2,443 meters over negative 9 point. This can be positive in this case, just because time should be a positive number. So we multiply 2 times 443, then divide that by 9.81, and then we square root it. And we should get this t should equal to 9.5 seconds. So that is it for the practice. More practice, make sure that you do this before the test. It will help you a lot. And that will be it. Thank you for your attention.